Hey everyone, this is a quick video just to talk about a couple of theorems that we'll be using in finding zeros of polynomials. And these include complex numbers, so these weren't zeros or weren't theorems that we talked about earlier. So with the first one, this is the fundamental theorem of algebra, or sometimes I just call it the number of zeros theorem. It says if p of x is a polynomial with degree n, then they're exactly in zeros, including complex zeros. So this could be something like if I had say x cubed minus 5x plus 1, or any polynomial, right, that I want to write down. I'm looking at the degree, right? So this highest number, which would be a 3 for this one, means there's going to be exactly 3 zeros, right? And they could all be real numbers. Maybe one of them's real, 2 complex, or something like that. But there are exactly 3 zeros if I include the complex zeros. So this is very useful when I'm looking for the number of zeros. Just knowing how many there are that I'm looking for can be pretty useful. So we'll use this in a second. The other theorem is what's called the conjugate zeros theorem, and this is for complex numbers. So sometimes they'll throw in this complex conjugate zeros theorem. It says that if p of x is a polynomial with integer coefficients, right? So could probably even be real coefficients for that, but usually ours are going to be integers. Then any complex zero must occur in conjugate pairs. So any complex zeros, that'd be something like, say, a 3 plus 5i. If that is a zero, it's conjugate, right? So 3 minus 5i would also have to be a zero, right? So these are going to occur in pairs because when I multiply out all my factors, the i's are going to disappear, and that only happens if I have these conjugate pairs. So what we're going to do with this, I'll give you kind of a sneak peek, is take a look at what could be the possibility of zeros in some of our problems. So here I have like this y is x cubed minus 5x plus 2. So that would be polynomial with a 0. One thing we'll be looking at is, right, if I have a nice 0, like so this 2, right, is a nice 0. How do I pull that out and figure out what these other two are, right, as an exact number? So this is some decimal involving a root, but what are those as exact numbers? So like I think this one might be square root of 2 minus 1 and square root of 2 minus 3 or something like that. But exactly what those are, right, is something that we would need to determine. Some of the problems I would say in general, right, we may not be able to do. So if this were, say, a plus 1 instead of a plus 2, right, these zeros, right, are going to be all something involving roots, right? So we don't really have a nice number to start with. And none of these are rational zeros because the only possible rational zeros would be factors of 1 over factors of 1, which is 1. And that's not going to be a 0. So the rational zeros theorem doesn't help on here. So this is one where you would really have to go through some more advanced work, try to figure out the exact values of these guys. It is doable. There is a process to solve that, but it is pretty long and involved and a little bit beyond what we're going to do in this class. So just keep in mind there are some of these polynomials out there that you may not be able to find all the exact zeros for right at this moment in this class, but you could still get the approximations off a graph. It could be also, if I said this was maybe instead of a plus 1, let's make that a plus 7, right? Something like this. Then this graph does have one real 0, right? It's right there. And it also has 2 complex zeros, right? Because they're not real. They don't cross the x-axis down here anywhere. But there are 3 zeros. We know from the number of zeros theorem, right, or the fundamental theorem of calculus. There are 3 zeros, including complex numbers. So one of these is real, and then the other 2 are complex. If this is a nice number, then we'll go through how to kind of figure out, all right, based on that nice number that I know is a root, what would the two complex numbers be that solve this out. So that'll be something that we do in another video. I just wanted to introduce you to those theorems. That way they won't be completely new when you look at the other videos. All right, we'll catch you on the next one.